Good evening, everyone. Welcome to this session. We would just wait for 2 more minutes to start the session. So, we are waiting for others also to join. Mahesh sir, we could start the live stream and the recording as well now. Okay. So, good evening, everyone. Thank you for joining this session. This is a very exciting session, and the topic is pathway to become data science consultant and the next 10 years in data science consultancy. So, my name is Afreed Kauhar. I'm representing the Student Placement Council, and I'll be moderating today's session. So we are privileged enough to have our speaker as Mr. Naveen Reddy, who is a manager at Deloitte Consultancy, specializing in strategy, analytics, and mergers and acquisitions within the analytics and cognitive decision. So, Sir has done Masters of MBA Administration, Masters of Business Administration, and he also has a bachelor's degree in Electronics and Communication. So, his career spans various industries, including telecom. He has also been a part of FMCG, retail, and he has actually extensive experience in data science analytics and training individual organizations in these fields. Now, he has an experience of over 16 years in this industry, and Naveen sir is a leading expert in data science consulting and the best person, in fact, the best person to guide us on this topic here today. But before we begin, a few things I would want you all to keep in mind is that please keep your microphones muted during the presentation to avoid any background noises. And also feel free to post your questions in the chat box. We'll have the question answer sessions towards the end where sir will be answering or addressing all your questions. And now I would not delay any further. I would welcome Naveen sir first of all, and then sir, the virtual floor is all yours. Thank you so much for being here.
Thank you, Afreen. Thank you so much. So, thank you, guys. First of all, I would like to thank Indian Institute of Technology Madras for having me today. It's an honor to probably address all you people. So, yeah, Let me just quickly share my screen and let's not get started. Let's not delay much time. So, um, yeah, I mean, we have a lot of people. Just to set the context, in case if you have any questions, right? So you can put it in the chat window. Questions are always welcome. So please feel free to add your questions in the chat window. I will try to take as many questions as possible, and I will try to answer them during the course of the discussion. If not, then I will probably take them at the end. So I do not have a PPT. So I would not prefer a PPT as well, because I feel like having a PPT and then going through that is not something which we should do in case whenever we want to have a discussion. So I will probably talk about the things that we had planned today, right? So our agenda for discussion, or probably our agenda today, what we'll be discussing is, we will see like what exactly is the pathway that we should follow if someone is aspiring to become a data scientist, right? And how exactly a data scientist would probably look at the next 10 years, what technologies will be there, what technologies will not be there, and all of that, right? So we will go ahead and then have a look at it. And before that, I just wanted to confirm few things from you. All of you are from the data science stream, right? So all of you belong to the part of IIT. Okay. So Ravindra, it's one note, Ravindra. Yeah. Okay. Wonderful. So I think, uh, okay, CSE, CSE and AI. Okay. Computer science engineering and artificial intelligence. Very good. A diploma. Okay. Fine. So I'll try my best to probably share as much as things I know, and then let us go ahead and then have a interactive session. I have access to your Zoom chats. Please feel free to post the questions if anything you want to know. Instantly, I can probably go ahead and then talk. So let me probably write some things so that you can probably refer to this, and then you will be in a good position in order if you want to refer this later and all of that. So today's discussion, what we are going to talk about is, the first aspect that I'm going to talk about is, we will understand the present DS landscape, right? So we will understand what is my current data science landscape that is there in the industry. So there could be a mismatch, or there could be a gap between what we see in the academics and also what exactly happens in the industry. So I would probably take you through that in a nutshell. So that is one thing that we are going to talk about it. And second thing that we are going to talk about is the crux. I mean, here I would also talk about a simple pathway, how you can learn, and also how you can pathway to becoming a DS data scientist. Okay, so this is something that I'm going to talk about. And the second thing that we are going to talk about is, what is going to be the trends. Okay, so we will be talking about the next 10 years in consulting. So specifically, I will keep my discussion towards data science consulting. So I will give you two perspectives here. So I'm going to give you a deeper perspective of how the technology evolution is happening and how you can keep up to it. And also I will list down few trends so that are going to pick up according to whatever things that I know. So these are two things that I'm going to talk about here. The third aspect that I'm going to do is a summary, right? So in this summary, what are you going to do? The key takeaways. So this is going to be a little interesting for you, because this is where you will know what are all the tech stack that you might have to follow in order to probably put yourself in the next level. Plus, I'm going to give you some books. So tech, technology, how you can probably pick up the things and how you can go ahead and then do it. Some books with respect to to technology, and also some books with respect to non-technology. So that will come in use for you to have a vision, right? So without vision, you can't go ahead, right? So you can't see what is going to happen. So to get a vision of what is going to happen in the, let's say, next 5 years, 10 years down the lane, so these books can actually become like a stepping stones. I'll give you the links and all of that. We will basically go ahead and then get started, right? So this is something that I have in store today. So I'm excited to discuss these things with you. Just want to know, like, these things sound interesting, right? Can we get started, guys? Yes. Okay. Rahul, Srinath, Ram, Sakshi. Okay. Wonderful. Very good. Cool. So in the middle of our discussion, if any one of you have any question, please feel free to ask. There's nothing like a simple question, silly question, whatever. A question is a question. Feel free to ask. No problem. Okay. So let's get started about the current industry, or maybe I'm talking about the DS landscape that we have today. So all of you might have studied data science from a perspective of all your supervised learning, unsupervised learning, and then how to solve some problems. You might have understood Python, you might have understood SQL, and apart from that, anything else? I'm just asking. You can ask your questions in the chat also, no problem. Harsh. Machine learning, yeah, machine learning. Then data analysis, web scraping. Okay, fair enough. Okay, deep learning. Okay, SQL, deep learning. Okay, wonderful. But my question now is, do you think Gen AI, okay, that's a good term. Statistical analysis, very good. Vasishta is saying statistical analysis. Okay, data science and algorithms, wonderful. So my question to all of you right now is, do you have a perspective where you are connecting all these things to know how the data science landscape is built? I'm just asking. You can say yes or no, not an issue. All of you have learned statistics, wonderful. All of you have learned machine learning, Python, wonderful. But you should probably understand, okay, foundation level, explore it. Okay, fine, fair enough. So what I'm going to do is I am going to probably coin a term here, which is nothing but data science as a domain. It has multiple phases. Phases as in not PHASES phase, no. It's multifaceted domain, which means it has lot of things involved in that. It's not like you learn Python and you become a Python developer. You learn Java and then you become a Java developer. No, it's not like that. Data science is a multifaceted domain. The major pillars, or probably I can say, just to put it in very simple terms, the major pillars, or probably I can say what constitutes of data science, is the first thing is nothing but your statistics plus math. Okay. Stat and math is something which is the foundation of data science. It could be machine learning, it could be artificial intelligence, it could be generative AI, deep learning, anything. Stat and math is the foundation. So there's no looking forward from that. Along with stat and math, so what you have, the next thing we need to talk about is programming. So why do we need programming? So all these things I'm going to explain it to you in detail. I'm just listing down these things. So once you understand stat and math, once you understand programming, the next thing that you need to probably understand is your what can I say? Data management, little bit of data management. I'm not saying much of it because it can be considered in data engineering as well, but let me put it. The second thing is your machine learning, deep learning, all these things. Okay. So this is something that is going to be there. Tarang, I've taken your question. I will explain the gap between the industry and the academics. No problem. How are you going to bridge it? Let me make a note of it. Give me a second. I'm going to address that. Okay, that's an important question. So probably I will address that in the end. So coming back to where we left, so data management, machine learning, deep learning, this is something. And another thing that you can consider is visualization. So I will take you through deep. I will talk about technologies, what are there, what are the things that you do, all of that. Visualization. Then you can probably put cloud. I will also put something called as MLOps here. MLOps is something. This is one aspect. Apart from this, you need to have some domain knowledge. So if I were to tell data science as a domain, as a landscape, so these are all the pillars that we have, right? This is something. And Harsh is asking me, as Gen A is becoming more and more prominent and integrated, how it fits in the entire landscape of data science. I will take that, Harsh. That's a good question. We'll answer that. I will tell you. Okay. What is cloud computing skills? I will not, cloud computing is not required, Shibashish. Let me clarify that. Okay, DSA also I will put this, no problem. AWS, everything will come now here. I'm going to cover all of that. So what all technology trends, tech stack that you want, I will write it here. So my question now to all of you is, do you agree with me? These can be the contents of the data science landscape. Let's say, for example, if you want to solve a data science problem, do you think these are necessary for someone, or probably in the organization? Do you think these things are needed, or probably these are important? And few of these things you might have heard also, right? You might have heard about machine learning, data science, and all of that, right? Okay. Now, let me make a list of all the things that are there in this. So you will get a better idea of what you're learning, where things are, and then how you can connect the dots. So as I told you, so you need to connect some dots here. So I will tell you any suggestions to learn statistics so that we can visualize and learn in a beautiful way. Shivam, there's a book, Applied Business Statistics, Ken Black. You can use that. So I will highlight that book in the end as well, Shivam. Not an issue. Okay. Coming back, so let me basically list few things in these topics so that you get an idea what are all the things that we have. So in stat and math, what do we do? Right? Whenever we talk about data science, in stat and math, what are the major things that we look at? I'm not going to write an exhaustive list, but I'm just trying to make some points here. So basically, you can do something like descriptive stats, right? So descriptive stats, you have inferential stats. Then you can probably go to your hypothesis testing. Hypothesis testing is one thing. Then you have ANOVA, one-way ANOVA, two-way ANOVA, MANOVA, MENCOVA, etc., etc. Then you can also have the concept of probability. Probability concept is really important. Then you can have linear algebra, right? So having said that, yeah, control limit theorem, all of that comes under this thing. So as I told you, I'm not going to go into the exhaustive list of all these things, but yeah, this is something which you need to go ahead and then do it. So Harshit, ANOVA stands for analysis of variance, right? So there are multiple ways how you can go ahead and then talk about ANOVA and everything. So there are multiple ways of ANOVA, right? So one-way ANOVA, two-way ANOVA. You can probably go through that, uh, keeping time in mind. So I'm not going into the depth, but you can always go ahead and then explore that, right? So this is basically your stat and math problem. So whatever things that you do, right? So you write a linear regression problem, or you probably build a logistic regression model. Whatever things that you do, or whatever things that you build, everything has a math back into it, right? So either matrix will be there, right? So or you will also have some things like linear equations will be there. So lot of things, right? So majorly linear algebra will be there. So this is basically a high level list of the things that you can probably keep it for stat and math. Now, the second thing that you get is programming. So in programming, what are all the things that you might probably go ahead and then list out? What all programming languages you might know, right? Programming, R, okay, others, very good. R programming, Python, SQL, wonderful. So I'm going to list the same thing. So when it comes to data science in specific, okay, there are a lot of programming languages, no doubt. But when it comes to data science in specific, we look at R programming is one of the programming language. You can use Python programming as one of the programming language for writing your machine learning models. You can also put SQL. So SQL is something that you can probably go ahead and then have a knowledge for data manipulation and everything. So majorly, I would recommend these three things. However, the more weightage can be given to Python and SQL compared to R, I will tell you, because R is known as a statistical programming language, right? So compared to Python, R probably what I can say is I won't use the term flexible enough, but I can say Python has a larger presence when compared to R in the data science community. So probably I would like to put it like that. Okay. So Aman has a question here. Can Java help in this? Java, I don't think so, Aman. You can do some things, but no, not things, not with respect to Python. Siddharth and others, Pranit, Siddharth, I will tell the books in the end. Just give me some time. So in the summary, I will basically tell you. Okay. Java, as you people say, it can be used in big data, but not with respect to this. So we will see. We will look at all of that. Varma is saying, would like to understand what will be the scope of in coming years. We observe trends, many companies, all the solutions profitable. Okay. So the trends we are going to talk about it in some time, Varma, right? VBA, Excel, all of them are classic. We need them. There's nothing like you don't need VBA or Excel. It is compulsory required. So programming languages, I just made a list of Python and SQL, right? So this is something that you can probably go ahead and then understand. So in data management, so this probably I can keep it in one domain, which I can call it as data engineering, right? I would keep this a little separately. I would not connect it with the data science. Even though you do some kind of data analysis, data wrangling and everything, I would put it into the machine learning itself. So this I will probably keep it a little isolated right now. Just to keep it in the landscape, I've put it, but let's keep this little isolated because we can consider it as data engineering, right? Now, to briefly talk about our machine learning and deep learning, what comes to your mind when I say machine learning, right? So three types of machine learning. What is it, right? I mean, I'm just trying to put them in a very simple way, right? So you have your supervised and then you have your unsupervised. So I'm just putting these things. So in supervised, you have some types of algorithms. In unsupervised, you have some types of algorithms, and then you also have certain unsupervised, semi-supervised, reinforcement, etc., etc., etc. A lot of them are there, but I'm not going to list them. Linear regression, logistic regression, decision trees, all your ensemble models, your clustering models. So you know that better, right? So this is something which I would probably go ahead and then put it. Now, when you talk about your supervised learning and unsupervised learning, this is a core where you're trying to solve your machine learning model. I mean, solve your problem that is coming from your business. Okay. I'm going to connect those dots as well. When we talk about visualizations, what tools come into your mind, guys? What tools come into your mind when we talk about the visualization? The first and the foremost, you can probably say Tableau, right? Wonderful. Power BI. Then Tableau, Power BI, Grafana, ClickView, ClickSense, etc., etc. There are some inbuilt cloud visualization tools as well. You have Amazon QuickSight, and then Google. What's the Google Data Studio? Yeah, Google Data Studio. So you have visualization tools. Plotly, all of them are libraries. Looker Studio, it is called now. Yes, Shirang, correct. Harsh, thank you. Yes. So these are some tools that you can probably go ahead and then keep in mind, right? Then let's list this. So cloud, what all clouds that you have? So I can probably put these things into separate. Cloud, majorly all of you know AWS, GCP, Azure, and MLOps, orchestration. Anything comes into your mind when I say orchestration platforms or orchestration tools? Apache Airflow. Harsh, I will tell you. Very good. So little bit of Docker, okay, Docker plus Kubernetes. This one thing you can basically keep it. Airflow, Apache Airflow. You have Kubeflow, you have MLflow. Okay, some of the orchestration platforms. We'll see all these things. Now let's talk about the domain. So what all domains comes into your mind? Let's say when I talk about data science or whatever, what domains? Where can I apply my DS? So first thing I would probably say telecom, right? Retail, FMCG, FMCG retail, manufacturing, then defense, finance, banking, etc., etc., etc. The list keeps on going. You can apply it wherever you want. Correct? Agree? Is there anything that we missed here? So this is basically the outline for my DS landscape. Everything, transportation, airline, almost everywhere you can put it. Done? Any questions so far? Whiteboard is not visible, Harsh. Okay. Is my whiteboard visible to all of you?
Yes, sir, it is visible. Harsh, probably you could rejoin again.
Probably rejoin
Yeah.
Harsh, no problem. So you have a clear understanding, right? You have whatever things that I wrote. There's nothing. There's no missing piece, right? Right now, you have an utmost clarity on what I explained it to you right now. No problem. Okay. Now let's go ahead and then connect all these things. MLOps, I will tell you. So now I'm going into the deeper dive. So I just told you a list of all the things that we basically, I mean, as people who aspire to come into this domain, so these are some things that you should be aware. These are some things that you should know. Okay. In the end, I will tell you what are the things that you need to pick up, and then what are the things that you need to basically go ahead and then use. So those things we will see. Now, how exactly these things work hand in hand, right? So now you have all the parts. Let's join them and then make sense of all these pillars, right? So how every pillar will shake hands with each other and then try to solve a problem, right? Now, when I talk about a data science problem, there needs to be two things. There has to be two things for me in order to go ahead with the data science problem or maybe get a solution for that. Any guesses what are those two things? Any guesses? There has to be two simple things for me. Saravana, very good. The first thing is data. Wonderful. Then the second one, exactly. Harsh on dot. Harsh Abu, very good. Right question is nothing but a problem. True. So if you want to go ahead and then solve something, you need to know what you're trying to solve, first of all. That's a problem statement. Second thing is the data. So there are different ways how you can formulate a problem statement. after understanding the data, right? So initially you may not know the problem statement also in some cases. You only know that the sales are decreasing. You only know that the customers are churning. But why those customers are churning? Why the sales are decreasing? Why my profit percentage is decreasing? Those things you may not know in the initial stage. So there are some different levels that you need to deep dive into the data to understand and formulate a problem statement. So that is a different ballgame altogether. Let's not go into that. What I'm going to talk about is the data and the problem statement for you will come from which of these domain, right? Will it come from stat? Will it come from programming? Will it come from MLDL, cloud? Where it comes from? Where are you going to get the data and where are you going to get the problem statement from? You're going to get it from the domain. Brilliant. Wonderful. It is from the client. It is from the domain. Correct. So your domain will give you the data plus the problem statement that you need to solve here. Right? So the domain gives you. So if you look at telecom, you might face a problem of customer churning. You might face a problem of targeted marketing. If you see retail, you can have inventory management, FMCG, you can have like probably in supermarket, you might have to uh, keep the products together, right? So you might have problems in doing all of that, how to increase the sales and everything, right? So in banking, you might have a problem for loans, right? So who is eligible, who will be a defaulter, lot of problems, right? So every domain will have its own set of problems that you might aspire to solve. So basically, your data and the problem comes from your domain. So this is the first thing that you need to keep in mind. Once you have your data and once you have your problem, so my entire objective right now is to convert this problem into a math based problem or a statistics based problem, correct? So I cannot just say that, okay, fine, I'm getting less sales or I'm getting more churn or something like that. You need to probably convert into a problem statement with some kind of data backing or proof telling that this is why it is happening. So what you will do here is whatever data you have, you will do an analysis, right? So descriptive statistics, inferential statistics, you will do your hypothesis testing, all these things you will do, and then understand, explore the data, and then you will probably create a problem statement here, correct? So from the data, whatever things you had, you have arrived to a state where you come up with a problem statement. So how can you give an example how we convert problem into a statistical framework? Harsh, I'm not saying you convert it into a statistical framework. My entire objective here is when you have a raw data, right? So when you know what you're trying to solve, with the help of statistics, you can explore the data in a much deeper level, understand your data better, and get more clarity on the problem, what is happening, and what you are highly likely to solve. You cannot convert it into an equation, right? Does that answer your question, Harsh? Okay. Now, once you have this particular problem statement, what is it next that you're going to do? So whatever I'm trying to tell you is on a little high level. I'm not going into the deep dive of all these things. Should we use visualization? You can use it, Priyanshi, not an issue. You can use it, right? So let me continue from here. Once you have this particular problem statement, what you're trying to do with this problem statement, you are trying to categorize this problem statement either into a supervised learning problem or an unsupervised learning problem. You have list of machine learning models here, right? You might have to categorize your problem statement into one of the category and use some of the machine learning models to solve that problem, correct? Agree? So let's say for example, you basically you take a random forest here. I'm just giving you an example. You took a random forest here. Now, Your problem statement is there, your random forest is there. You're not going to solve your random forest on paper. You basically solve it in your computer or cloud or whatever. So as humans, to interact with the computer, we need a programming language. Obviously, this is where my programming language comes into picture. So by using the power of statistics and programming plus compute to solve your business problem, you are leveraging your machine learning algorithms right now. Getting it? You're trying to interact with your computer using a programming language. This is clear to all of you right now? I mean, programming as in not only Python, you can also put SQL because you are using SQL to do all this data manipulation, data munging, and all of that. So I'm just giving you an example here. Now, what happens? Tell me, random forest is basically a classification or I mean, I would probably say, I mean, this is simple regression classification or what it is. What do you get as an output? To put it in simple terms, you basically get a regression also in your random forest. You get a classification also in random forest. But keeping in mind the most widely used application, I will take it as a classifier. What is the output that you will get? You basically get your accuracy, you basically get your precision, you get your recall, you get your sensitivity, you get your specificity, then lot of other things, right? So you can get all these things. Now, these things are technical terms. Yeah, I will also put F1 score for Akrit, no problem, right? Now, uh, Mrigankar, I will note your question. That's a good one. So I will basically answer that as well. Not an issue. Okay. Mrigankar and then Tarang. Okay. Yeah. Now, coming back here, let's say these are the outputs of your model. As students or probably as data science professionals, we understand and we can make sense out of all these parameters. Do you think if you take this to your client or if you think you take it to a domain expert, will they be able to understand these things in any way? If you say sensitivity is this, will he be able to understand? Obviously, right? No, never. He may not be able to understand that, right? Okay, very unlikely. Correct. Now, in order to make them understand, you have to make it simple, visual, and more appealing. So that is where your visualization comes into picture. You need to build some dashboards here. Got it? So you need to build some dashboards. This basically has the solution, let's say, plus you can show it to the client, correct? What is the solution? I mean, I'm just putting it as a solution. It can be an insight, it can be a solution, it can be an analysis, whatever. Now, once you bring this here, this solution for your problem, the cycle, don't you think is complete here? Whatever data problem you had, you took this route, made a problem statement, used your programming languages, classified it into either one of the machine learning models, built it, then visualized it, then you're trying to share it with the client. Don't you think this cycle is complete right now? MLOps is something that comes, Harsh. I will tell you later. Now this cycle is particularly complete. Now what happens? This is a single iteration that you have done. So in single iteration, you might not be able to put your solution into production. So this is where your cloud and MLOps comes into picture, right? So you do all your training, testing, everything here itself. I'm not putting training, testing, everything. So you build a machine learning model traditionally, and then you complete the cycle. Now, what happens is this entire framework, what you have built, right? The data science, problem statement, and then your code, including your code which is there in your GitHub, including your machine learning model, your champion, challenger, etc., including your dashboard, everything. What you will do is you might have to deploy into some cloud. It needs to go into production. Correct? Don't you think so? Whatever you have built as a repo, or probably whatever you have built, you need to take it and put it into cloud. Either you choose GCP, you take Azure, you take whatever it is. Correct? Now, what happens once you put it into cloud, it needs to run in real time. It needs to go into production. You can put it in GitHub also, Harsh, no issues. You can put, see, GitHub is just a repository where you can store your code, right? But AWS, GCP, Azure has different functionalities. They have notebooks, they have compute, they have many other things, right? Your GitHub doesn't give you compute power. You cannot run your machines on GitHub, correct, na? GitHub is basically used to put all your codes here. See, whatever code that you write, right? So this you can store it in GitHub, no issue. So there's a repo, you can use it, no issues. GitHub, GitLab, anything that you can use. But what happens, right? There are notebooks in your cloud. Those notebooks will leverage the code that you have put it in your GitHub. Or you have inbuilt repositories in your cloud itself. Correct? You have a repo in AWS, GCP, right? You have repos there also, right? Instead of GitHub, you use the repo that is there. Let's say we are confining it into a single cloud environment, let's say AWS or something. We have all the things that we need. You have a code repository, you have computing power, you have notebooks, you also have model monitoring, and also you have model orchestration. I will tell you what is model orchestration in a minute, but till here you are able to connect with me. Are you with me in the flow? Experienced jobs, okay, Navil. Navil, you have to get a internship or something and then get into the industry, Navil. So it's not like always there's an demand for experienced, but there are a lot of options for fresh graduates as well. Yeah. So data reviewer and data analyst. Kirutika, data reviewer is something which I'm hearing it for the first time. Probably I need to explore that. I'm not really sure. Uh, Pardon me for that. Anyway. Okay, let me see. I mean, if I can get some input on that, I'll tell you, because data reviewer I haven't heard. So anyway, now what happens? No, you put all your thing into, let's say, AWS or maybe GCP or Azure or whatever cloud that you have. Now, to make your model run on a real-time basis, once in a day, twice in a day, once in an hour, or something like that, you need to build pipelines. Okay, pipeline is nothing but they are building blocks. So how are they basically built? So basically, pipeline will have all the building blocks, right? So if I were to probably write a simple pipeline here, it will have certain kind of building blocks. So this is basically data extraction, right? So this block is data cleaning. This block is your machine learning model building. This block is basically your evaluation. This is basically your, let's say, scoring. So like this. So there is a pipeline that is being built, which runs automatically. So one by one, these tasks will be complete. So this is facilitated by something called as your orchestration. So like Airflow, Kubeflow, MLflow, etc. So I can probably show you an image, okay? Airflow pipeline. So you just check this pipeline. See, this is how a Airflow pipeline looks, right? So I'm just showcasing this to you. So these are several tasks that are there here. Okay, this is your data cleaning, this is your machine learning model building, and then this red means it is failing and green means it is success. So this is how your orchestration happens in real time. So this is one thing you can probably keep in mind. And once all of these things are there in the cloud, what happens? You can probably put your machine learning models into production. So this is what the current data science landscape is, right? Having said that, right? So any questions to anyone right now? Is this clear? Whatever I'm trying to tell you. Combining multiple tasks in the right manner, exactly, Harsh, to make them synchronously run one after the other to get the desired result. So that's what uh, orchestration is basically all about. This is clear to all of you till here. So having said that, there are some things which you may not be involved much. Data management, data engineers role will be there. Visualizations, you have BI experts. Cloud and MLOps, you can have deployment engineers, MLOps engineers. So apart from this, programming, stat and math, MLDL, if you're able to focus more, that will be the major focus for you as data science professionals. So that is one thing which I want to tell you. Having said that, right, today's data science landscape is not like the traditional data science landscape, right? So it's not like the traditional data science landscape that we all had. You don't, if you know just building machine learning models, that is not sufficient today. You might have to probably understand how other things work in this domain as well. So what are the things that probably I can stress is, in case if you are looking for excelling in your DS, probably Python SQL is something that you can prioritize, a high priority. Stat and math, yes, a little bit. Good to know things. Then you need to understand the core of supervised and unsupervised learning. So these are the basic and the must haves. Along with that, know either one of the cloud platform to a basic level and know one of the orchestration tool to a basic level. So you should be able to build a simple pipeline and deploy it. So if these are the things that are there, then the things will be better for you. Don't go with only the traditional way of like building only machine learning algorithm, learning only statistics. No, that is not something is the requirement of the day. You mean ML algorithm for math perspective, you need to focus. Little bit of math is required, Harsh. You need to know, right? So whenever you're trying to monitor your machine learning model, if you don't know how stats work, right? So how exactly you're going to do it, it is going to be difficult. Not only knowing programming is important, knowing statistics to a basic understanding is compulsory. It is needed. Okay. These are some things which I would probably suggest you to keep focus on. Traditionally, what we used to do, learn Python, learn a little bit SQL, learn a little bit of machine learning algorithms, and then we were like, okay, good to go. But now the landscape is a little different. I'm not talking about generative AI and all other things right now, but only keeping things in a data science perspective. So these are some things which I ticked in the blue pen is something which I wanted you to focus on more. Sir, I've been reading about machine learning system design from Evidently AI. What does that fit in here? Okay. See, Vashishta, Evidently.ai is what I can say. It's like a suit which you're basically trying to use for machine learning monitoring. So machine learning monitoring means whenever your model goes into production, I'll make it very simple for you. Okay. The benchmark, let's say your machine learning model here, this assume that this is your time and this is your accuracy of your machine learning model. Okay. This is your day one, your accuracy is at 80%. I'm giving you a very simple example. You expect your model to perform in the same accuracy as the time goes. So this is your day one, day two, day three, day four, day five, day six, something like that. Now, unfortunately, your machine learning accuracy keeps on dropping like this. You might have set a threshold for 75%. If your machine learning model accuracy drops beyond 75%, you need to go ahead and then retrain the model. Okay. This process is called monitoring of the model. Okay. Model monitoring. Now, whenever you want to do this, evidently AI is something that gives you a lot of options. Lot of options, as in so many options are there. It basically talks about the what do you say, uh, model performance, or maybe I can say model decay, or maybe data related decay. It talks about terms which can measure this, which is CSI and then PSI score, right? And then you also have your KS statistics. It also has lot of statistical tests which can use it. Okay, right? So this is what evidently AI basically does. So you fit it in the model monitoring roadmap as such. Okay, got it, na? Saurav's question, I think someone has answered there. No problem. Akarsh, with the advent of GenAI, it has become easier to do technical aspects of data, some technical. How do you say that change has been in GenAI from experience should be more skill project? Okay, this is a little debatable question, Arshak. So I'll take that question. I'll take that question. No problem. You might have to integrate. Yes, that's a good term that Harsh has used. So we will take that question, right? This is clear to all of you till now. Mohammed Nabil, no, humans will not be replaced, my friend. Don't worry. I mean, even I'm having the same doubt, but with whatever things that I know, it doesn't happen. Sir, for future, is DS enough or DS AI is better? So see, it's not like data science or AI. Don't go into assumption that both of them are different things. Try to see both of them as a part of the same domain. So whatever you're trying to do, data science, right? That's a part of artificial intelligence. Artificial intelligence is much a wider domain as such, right? So you can probably go ahead and then keep that in mind. I'm very curious to know how much time would it take to learn all these things as a beginner. Siddharth, that's a very, very important question. So I will probably cover how you should learn as well. Okay. I will also put how to learn. I would probably take an example here. So Fenman, I will just talk about it. Okay. Don't worry. So this is something that we need to talk. So this is something that is all about the today's data science current landscape. So if this is clear, then I will go ahead and talk about what might be there in the next 10 years as such, probably we can see, so that you get a good idea of where you need to place yourself, what are the skill sets that you need to learn and all. And yeah, I take the liberty to extend the session by a few minutes. I know we just have 8 more minutes to go, but I'm sure in 8 more minutes we will not be able to do that, right? So I take the liberty to extend the
No
session
problem,
for
sir.
some more time.
Yes, sir, you
Yeah,
can
No
go ahead.
problem.
thank you. So if this is clear, I just need a yes or no. Whatever we discussed, is this absolutely clear to all of you so that I can go to the next thing? Yeah, good. Okay, this is going to be like a little story. Okay, for 2 minutes, I'm going to talk about this. So what exactly is going to be, right? So this has always been a curiosity to everyone. So what exactly is going to happen in the next 10 years? It can be in consulting or it can be in whatever. Okay, it can be in consulting, it can be in development project, uh, whatever the things. Now, whatever I'm trying to tell you is going to be a little deeper perspective. I want you to wear your thinking hats right now for a few minutes and then understand whatever I'm going to tell you. Okay. First thing that you need to understand is AI will shake up the entire world in the next 20-25 years. It is going to revolutionize the way that we look at the things, day-to-day things. It can be a simple cell phone. It is going to drive technology to greater heights. It is going to transform the way society is. That is going to be the next. And whatever I'm going to talk right now, it might sound like speculative fiction, right? So I might probably sound like a person who is talking or maybe speculating some things. Could be. I am not sure, right? So I have not seen the future. Okay. It could sound like a speculative fiction, or probably you can consider it as a methodical forecast, right? So based on some methods, we are trying to forecast the things, right? So these are two things that I would want to tell you. Now, guys, you keep your questions for a few minutes. I will probably give you my LinkedIn ID. You shoot the questions there. Feel free to message me. I will try to answer all your questions there. So let's probably keep our discussion here. Any questions? Welcome. I'll give you my LinkedIn, Instagram, whatever you want. You can probably reach out to me on that. Not an issue. Okay. Now, the next 10 years, if you were to look at it, this perspective, what I'm going to give you, comes from a little bit of thought process. Just understand this carefully. Okay. There are three levels. I'm going to make this thing into three levels, whatever I'm going to talk about. The first thing I'm going to talk about is technology. Okay. So, all of you know, whatever technology we had 10 years back, it's not the same today, right? All of you agree? Technology is ever changing, so we need to be like prepared. Mainframe systems, etc., etc. You used to use a floppy drive, now you have a pen drive, and then now everything is in the cloud. You don't have a physical storage. Who knew that storage is going to go virtual? None of us knew, right? We did not know that storage is going to go virtual. Wow, that is impossible, is what 10 years back we used to think, but now it is the reality. So technology is basically ever changing, right? So this is one aspect of it. Then the second aspect that you need to understand is basically the solution approach. The solutions, right? There will be new challenges, there will be new solutions as well, and also there will be new approaches as well in the next probably few years. What are the drivers for these things is something I'm going to talk about it right now. Okay. Technology is something which changes. This is basically like I can say evolution. Okay, technological evolution is what we can term this. But what is the main driver for this? So the main driver for this is basically the business needs, right? So business needs to improve, right? Business needs to improve. People want to make money, people want to have a better life, right? So that is the main need which is trying to give rise to all these things. But where the core lies in, so one thing that you need to understand here is, this might sound like a little uh, philosophical, but everything comes under something called as human curiosity. So human curiosity, I would probably keep things in two ways. Okay, I'm not going to elaborate it very much. I just putting this thing in green because this is something which you need to think about it. I mean, I'm not saying think today to learn and then do all of that. No, keep this thing in mind, because this comes very handy when you look at 10 years down the lane, right? So none of you are going to be students. 10, 15 years down the lane, you might be a VP or a AVP or maybe a CEO of some company. I don't know. So these things comes into mind whenever you want to do that. But I'm just trying to ignite that spark right now so that you have a basic understanding of it. The first thing that all of us should be aware is, whenever we are going to talk about technology or whenever we are going to talk about anything, our personal experience. So we are going to talk about from our personal experience, or we have learned it from somewhere. That might accommodate for less than like 0.001% of what exactly is happening in the world, right? Do you agree with me? Our personal experience or whatever we have learned in technology, data science, whatever, can can basically be less than a small fraction of what is happening in the world. Correct? Agree? Yes. But what we feel that whatever we know comes to approximately 85 to 90% of what is happening. Right? So this is something that we should let go. This should not be the perspective of our thoughts, we should basically go ahead and then get as much information as possible, as many perspectives as possible from the people who are veterans in the industry, who can probably guide or maybe tell or do whatever the things. So this could be one main reason why many startups fail also. They think they know, they think they're doing something which is going to revolutionize the world without understanding the needs, without understanding what exactly needs to be done, what is the requirement. I mean, if we know 90% of what is required, then none of the startups would have failed, right? Have you thought on that perspective? You're trying to address a problem. If that's the problem 95% of the people are facing in the world, I mean, obviously, right? You wouldn't fail, correct? Yes, you wouldn't fail, right? So this is something that you need to basically think about it. And the second thing is the time of our existence. So this also plays a very important role. So why this plays a very important role is, if you are a person who are born in the age of industrial revolution, right? The way you thought about all these things would have been different, correct? All you used to know is how a steam engine works, correct? All you used to know is how the mechanical things work. You need to go ahead and then see how lathe works, or probably how something mechanical works, correct? In the era of industrial revolution, right? So that is what we were, I mean, that is what we used to think. Let's say in the dot com boom, let's say in the 95, 96, or maybe 1990s or something, if we are able to work, we used to think about what exactly is an operating system, what exactly is a floppy drive, what exactly is a CD-ROM. So our thinking capability would have been limited by the time, correct? So that is something. Now we are in the era of data and evolution. So whatever things that we are exposed to, our thinking is completely limited to those things. We will not be able to see the futuristic things unless you expose yourself to some kind of what can I say, resources, or probably some kind of uh, trends that are going to lead, like generative AI, right? Do you agree with these two things? I mean, entirely left to your what do you say, uh, thinking capability, or maybe I leave it to your judgment, but this is what I feel. How much we know, and then the time of our existence, right? The time of our existence, Harsh, is nothing but, if you are a person who was working on the technology in the industrial revolution, the way you looked at the problem would have been different. You would have thought about 5 MB is a great storage at that time. If you are working on technology in 1990s or 95, 80 GB was a great storage at that time. The way you looked at technology was entirely different than the way we look at technology today, right? So I talk about, like, let's say 1 TB as a very large storage today. I'm just trying to tell you. But 5 years down the lane, who knows? Mobile phones might have 5 TB storage. We don't know, right? What is going to happen? So, keeping ourselves updated and then having this curiosity is always necessary in order to succeed in any domain. So, this is something that I'm going to talk about. Keeping these three things. So, human curiosity is the driver of business needs, and that leads to technological evolution all the way. So, this is what I feel is something that is going to drive the things, right? So now let me come back. So what are all the things that are going to talk about it? So I would probably say whatever I told right now can be a speculation. I'm not sure. But whatever I'm going to talk about right now is the trends that are happening. So the first thing is the latest one that all of you are talking about is Gen AI, right? So generative AI, let's say from the past 2 years, if you look at it, according to, I don't remember where I read this, according to some report, the search for Gen AI related technologies has increased by 85 to 90% in the last 2 years. So that is something. And one thing that I'm going to talk about right now is generative AI is not going to be a bubble. It is not a bubble, it is going to be a tree. So a tree that is growing its roots. the roots are deepening day by day. So generative AI is going to, okay, Wall Street Journal, is it Biswajit? Okay, I think so. I don't remember where I read it. Okay, anyway, thank you so much, thanks. So this is something that it is happening. So Gen AI things are going to grow. Then the second thing that it is going to come up is, all of you know, is deep fake. So deep fakes are also going, whereas the attempt, or probably the, what I can say, identify what is original and what is wrong, the authenticity, right? The governance, the security things are also increasing. So these are some of the trends that are going. In case if you are in any kind of consulting domain or whatever, the projects, also the solutions will be in line with these things. Along with this, there are so many apps that are going to be built on Python. So Python related app, right? So Python related apps, this is something that you are basically go ahead and then talk about it. And the last thing what I would probably like to tell you, the trend is, so people are looking for end to end based AI solutions. So no one is looking at a piece by piece solution. No one is looking at a small piece where you want to go ahead and then fix it. Everyone wants end to end AI solutions. So if you were to look at the trends for consulting, the focus would be generative AI, the projects, the applications, and the applications that are going to be on Python. So this is also one thing, and end-to-end generate and end-to-end AI-based solutions. So basically, these are going to be the upcoming trends, is what I strongly believe. So what is end-to-end AI solution? Example is, see, Harsh, no one wants someone who can give only machine learning model. No one wants who can use only Python. No one wants who can only do what do you say, deployment. People want someone. I'm not saying an individual perspective. I'm not talking about an individual, Harsh. Individually it is not that easy, but people, when they are coming to consulting, or probably people, or maybe let's say any multinational, if they are giving a project, right, they want it to be done end to end. So they're looking for someone, or maybe some company, who will be able to give a end to end solution, right? So they don't want someone to do visualization, someone to do the data science part. No, they want everything to be done end to end. So some apps, or maybe some platforms which can deliver that solution, so they would preferring such kind of a solution. A very simple example is, let's say, Harsh, you have your AWS, right? So AWS has everything that you want for data science. It has a repository, it has a compute, it has notebooks, it has visualization, it has orchestration, it has model monitoring, it has what do you say, everything. Data IQ, correct, Biswajit. So end to end. So those kind of applications, or those things that are going to go ahead and then increase. What is the scope for a freelancer for an end-to-end solution? That depends, Harsh. I mean, I may not be able to comment on that because uh, not sure, right? So scope, I don't know. That's a very open question. So that is something. Could you please tell us how data structures and algorithms are related? Okay, data structures and algorithms, obviously you need them to manage data, SQL and all of that. So that is one thing that is there. Is Databricks or AWS SageMaker end-to-end platform? See, Vasishtha, Databricks and SageMaker you can use to build your model, create experiments, and then what do you say, monitor, or probably monitor your machine learning models. They're not end-to-end solutions. End-to-end solution means Databricks is basically from Azure, and then AWS SageMaker, they are one of the part of the end-to-end solution. So your Databricks and also your SageMaker help you to build this machine learning model and do some kind of model monitoring. But if you want your programming, that is also available in your AWS. You can use Jupyter notebooks. If you want to do some kind of data engineering, Redshift is there. If you want storage, S3 is there. If you want to build your MLDL, as you said, SageMaker is there. For visualization, you have what is that called? AWS QuickSight, right? AWS QuickSight is there, and then it also supports Airflow, Kubeflow, everything. So AWS has a platform that can give you end-to-end solution. So that is what end-to-end solution is all about, right? So Ram's question is, sir, you are talking about tech revolutioning the world. How will data science help laymen from every field of life help solve their problems? Even tech today is not able to help the world correctly. Yeah. So see, Ram, I would like to make a simple statement here. Technology will never give you solution for everything. Point number one. Point number two is technology will make our life easy, right? So that is one thing. If you can see for a layman, I will just take a very simple example. Previously, we used to write a letter and put it in a post box. Now you can write an email. That's an advent of technology, right? So that is one thing. And second thing is, let's say you want to make a payment, right? You might have to go to the bank and then do it. Now you can probably do it via your payment apps, right? So it is going to make your life simpler. It is not going to solve any of your problem. Technology will not help you to make money. It can only help you to transfer your money easily, right? So I mean, that's on a very lighter note. I'm just trying to tell you, Ram, technology is meant to make our life simpler, right? So small problems which can be solved, right? It will make our life simpler. It will not eradicate all the problems that are there. So that is what my take is. You can always share your opinion also. We can have a discussion on that. Okay. One question I will take, and then probably we will summarize, and then we can have a Q&A for some time. Okay. Data science is limited to large companies, large amount of data, small, medium businesses. Okay, independent data science consulting for such businesses near future is financially sensible. See, Akarsh, what you're asking is there are two aspects to it. The first aspect that you're covering is based on technology. Okay, technology wise, fine, fair enough. The second thing that you're talking about is from a business perspective, right? So when you talk from a business perspective, right, if you are trying to establish as an independent data science consulting firm, you have to be really solid. There are a lot of business nitty-gritties involved in that for you to establish, right? So there are two aspects that I'm talking about. The first thing is technology. Okay, you're technologically very sound, wonderful, not an issue. But do you have a reputation as a business? Do you have a brand name as a business? There are so many things which you don't know, right? We are not MBA people here, right? We are technology people. We're looking at from a technology perspective. Just because we know technology very well doesn't guarantee that you will get a business. So that is something which I can probably tell you, Arshak. Okay, Abu. So that is what I'm trying to tell you. Okay. Now, let me basically summarize the things. So, and then we will probably have a small round of Q&A. Just a quick summary I will give you. I will probably share you some links as well. Tarang, I will answer your question, how to keep up with the technology. See, key takeaways. First question is industry and academics. What is the difference? See, industry and academics, Tarang's question, academics will help you to learn the ABCD, right? So you will learn the basics, you will know the things, what are needs to be done. But in the industry, it's an entirely different ball game altogether. To bridge that gap, what you can do is you can take up internships, you can probably try to solve your own problems, and then you have to get working in a real time industry. So there is a gap between the industry and academics. That gap will always be there. Bridging that gap is always a challenge, right? So that is one thing. And then Mrigang's question, will certifications add more value? Personally speaking, they may not, is what my take is. Okay, having a certification can give you a little bit of resume weightage, but it doesn't give you an edge over something who knows technology very well. You know how to code, That is what you need. None of the certificate will come close to it. You know how to write a machine learning model. That is what you need. You don't need a certificate for that. Okay. Biswajit, I think we can take that offline. I'll give you the LinkedIn connect so you can probably ask those things. So we can probably keeping time in mind. I may not be able to take all your questions, but I will take them offline and then I'll revert back to you on that. Okay. That is one thing. So key takeaways. I think Mrigank and Tarang, those two questions I believe I am able to answer. So key takeaways, right? So what are the things that you might have to understand in this particular thing is like, let's say, I will make it as takeaways. I'll also give you certain books. I'll share my LinkedIn link, Instagram link, everything I'll give it to you. Don't worry. See, from a learning perspective, if you are not very comfortable with Python and SQL, that is going to be difficult. So you have to learn Python and SQL. So this is a mandate you can see. If you are in this domain, know Python and SQL extensively, really good. Okay, wherever you want, you go and then learn it. Doesn't matter. And whatever things that you want to learn are freely available in the internet. There are a lot of resources to learn Python, learn SQL. Many are there. Okay, this is one aspect. Then you might have to understand machine learning a little bit of depth and understand a little bit of MLOps. MLOps is nothing but how do you deploy a machine learning model into production? Little bit. I am not saying extensively. So this gives you the name of the technologies that you might have to understand in MLOps and everything. Just have a hands-on experience of that. Now, Python SQL is a must. How much programming does the data scientist do compared to a developer or a programmer in software engineering? So data scientist will do more than programming. He needs to think from a statistical perspective. He needs to know why a function is being called. He needs to know why a function is being called. That is one thing. Does in par with a programmer or a software engineer, Bhavik. Okay. Could you please tell why Trend prefers using Python over R? Okay, as I told you, R is a statistical programming language mainly used in academics and a lightweight programming language. It is given, I mean, lot of communities there. I mean, one main reason what I feel is R is having a little steeper learning curve when compared to Python. Python is easy to learn. That is one thing. Second thing is Python has a lot of libraries. Right now it is growing. And all these cloud platforms, right? So they give all your Jupyter notebooks and then Python extensively. So trend has been that R is usually preferred over Python. Okay, so that is one thing. Yes, Tarang. The question answer is yes. So this is one thing that you do. Whatever you do it a little bit more real time. Have your GitHub repos, have your codes and everything. Then the second thing that I want to talk about is have a Kaggle account. Okay, try to solve some Kaggle problems. Plus, you have your lead code. Use these two things. Leverage these two algorithm. I mean, leverage these two things. So these are two things that you can probably go ahead and then use it. So these things you need to be absolutely strong, right? Python SQL, there is no other go. You have to code. You need to learn how to code. This is one thing, right? Correct. Now, this is clear to all of you. Technically, what you are basically going to focus on initially. I mean, once you're done with this, you can go ahead and then understand the next things. You will have experience and everything. So if you want to refer to certain books, right? So I will probably recommend you few books, tech books and then few non-tech books. So you can basically go ahead and then check. So you can go ahead and then I mean, if you don't know anything, or probably if you want to learn DS like a novel or like a story, you can refer to something called as Bretlands. So Bretlands is the author name. I will show you the book links, how they look also. You can probably refer to it. Then for stats, you can probably refer to Ken Black, a good book. The most important book, what I would recommend is Introduction to Statistical Learning using Python, ISLP. So this is something that you might have to look at it. So these are three books which I would recommend you to start with. This is an important book. Go through this. This will help you to get an edge. I will show you the links also. So how these books look, I will show it to you. I mean, you don't have to buy them as such. PDFs are available. Britlands. This is the one, machine learning with R. I think there is one machine learning with Python also by Bretlands. You can just refer to it. Images I will show you just for your reference. Okay, see, this is how the book looks. Machine learning with R, Bretlands. So this is one book. Then Ken Black, Applied Business Statistics. Applied Business Statistics, Ken Black. So this is the one, the black one. This one you can refer to Ken Black. And the last one, Introduction to Statistical Learning with Python, Robert Tibshirani and Trevor Hasty. So this is the one. This is one of the book we need to go through. So good books. Start with these three. Maybe if you are connected, I can refer a few of them for you. So these are three tech books as such, which I would recommend you to start. Non-tech books, just to spark your curiosity, if you want to go through it instead of going through some fiction or something, go through this AI 2041. So this is a good book by Quifan Lee, I believe. Quifan Lee. So let's see. I mean, Quifan Lee. Then The Age of AI. This is from Henry, and another author name is Eric. I don't know the third author name. I don't know. The last one is Human Compatible. So Human Compatible. So Human Compatible, Stuart Russell. Stuart Russell. Yeah. These are the three books. Age of AI is a really good book. Yeah, Harsh. So these are the three books. Just, I mean, instead of reading a novel, so you can read them. So I'm just trying to show AI 2041. This is how the book looks basically. This is how it looks. You can refer to this. Then Age of AI. This is the one, Henry and Eric Schmidt. So this is the book that I was talking about. You can probably refer to this, and then Human Compatible book. This is also another book. Human Compatible, Stuart Russell. Hmm. Super Intelligence is also a really good book, Harsh. You can refer to that as well. Super Intelligence is also a really good book which you can read through it. Life 3.0, I've not read it. So maybe. No, yeah, lot of books, Srinath. Come on. I don't know. Anyway, these are three books which I can recommend with respect to AI. You can read it, Tarang. So these non-tech books are just for your curiosity. You can just go ahead and then read them just to get a good perspective. Now, I will basically tell you uh, a way. Sorry, give me a second. This is something which I want to tell you. Whenever you are talking about, right? You just go through the something called as a Ebbinghaus forgetting curve. Okay, so Ebbinghaus forgetting curve basically talks about how much information you will retain if you don't revise. So this I'm just trying to tell you because you tend to forget things very soon, right? So just try to read or maybe do a small research about Ebbinghaus forgetting curve. I'm sorry I've extended it like 50% more time, but this is something which I wanted to tell you. And Fenneman, there was a book I forgot. Um, okay, anyway, I'll not basically go ahead and then enter this right now. Anyway, book recommendations we'll see if we come into later, but this is something that you might have to. Brett Land's Ken Black, Introduction to Statistical Learning, and we will do it. Last question is, as every device has different kind of data like banking check, different data UPI, if new technology available, why we use old one? It may become hectic in managing data and research, so has to know both. It's about transition, Ram. So when you transition from old technology to new technology, right, you might have to sunset one technology. So you need to know how the technology works and how you can adapt to the new technology. Unless you know old one, you can't adapt to the new one, right? So there has to be a process of sunsetting the old technology and moving to the new technology. So that is something which you might have to go ahead and then get it. Okay. Quickly giving a recap now. DS landscape, we saw what are all the things that are there. So I basically told you all these things. And then I also told you about the next 10 years, how we are going to go ahead and then do it. I just gave you some reference of the books in a very nutshell. And I think all of you will have the recording for your reference. And since you're requesting the LinkedIn, I will just give it to you. This is basically my LinkedIn link. So I'm just putting it in the chat window. You can connect with me. If anyone is interested, if you are very much curious in Instagram, you can connect me there also. Anything. So I think you will be able to get the recording in the YouTube
Yes,
itself,
sir.
the
Yes, sir.
same link. Yeah.
Mm-hmm.
So this is the things, guys. Uh, pandas versus polars. No, not yet, Srinath. Polars is still nascent stages. Powerful, but yeah, we need to see. Okay. So this is something I had to discuss today with you. First thing is, excuse me for extending almost
No, sir,
uh,
it's okay. You can.
50 minutes. Okay, since Chatrapal is asking, just give me a second, Chatrapal. Since you're asking, right, let me just check the book name. I'll tell you right now. It's in my list. Wait. The book name of Feynman is uh, Six Not So Easy Pieces and Six Easy Pieces. Two books. Six Not So Easy Pieces. He has simplified how teaching can be done, Chatrapal. Six Not So Easy Pieces, and the second book is Six Easy Pieces. Six easy pieces you read first, and not so easy pieces you read later. Okay, thank you. Thank you so much, guys. Thanks for giving me this opportunity. I would like to thank IIT Madras, in specific the placement cell of data science, for having me. It's an absolute honor to be in between all of you people. Thank you. It's been really wonderful to share whatever knowledge or probably whatever things that I wanted to convey. Please stay in touch in case if anything is required. Thanks, Avijit, for coordinating this. I would like to take your name. Without you,
Thank
this
you, sir.
wouldn't have been possible. Thank you, Afreen, and thanks to everyone who are involved. Thanks, guys.
It's a
Take care.
great session, sir, and
Yes, sir.
extending like 30 more minutes. It's
Yes, sir.
actually uh, like we are very grateful to you. It's very interactive
Sir, in
sessions,
fact,
and
it's an honor for us to have you here.
yes, sir. And we have like constant participation of 140 plus, I guess. So that is very unique for sessions. Normally we so it's like it's with the number
Many
it
people
is.
watch it on YouTube.
Yes,
So,
and like on the YouTube, we have more than 1,000, I guess, 1,000 views is already. It's
oh,
a
wow.
nice session, sir. Thank you.
Yeah.
Thank you,
So I'm,
guys.
yes,
My
sir.
privilege to be in middle of all of you. Hope to be in person someday,
Yes,
Avijit.
sir, sure, sir.
Sure,
Someday,
sir.
sure. I would
Okay.
also urge everyone to please turn on their cameras so that we could take a snap. Srirang, if you could please do this honor to be the cameraman today.
Yes,
Yeah,
sure.
guys, please
Yeah,
turn on your camera so that we can have a good snap.
yeah.
Irang done. Irang, can we have your camera turned on?
Yeah, done.
Okay.
Thank you,
Thank you
everyone.
everyone for turning on
Thank
your
you. Thank you.
cameras. And thank you so
And
much, sir. So as we wrap up the session, I want to take a moment to thank Naveen sir for sharing all the knowledge, all the wealth of knowledge that he had, and he also shared his experiences, especially the data landscape which he presented, and everything was presented in such a lucid way. It was very much needed for us. Uh, and I think this session was very insightful for everyone present here as it was for me. So sir, thank you so much for guiding us for this data science consultant, and we expect that uh, in the future whatever comes into this field, we have a little bit of clarity now, anybody who has an aspiration to be into this field. So uh, a big thank you to you, sir, and we are really honored to have you here. Thank you so much, and thank you everyone for joining us and patiently being here with us. And also, the questions that were asked was also like a very important part of this session. The questions were actually very nicely put and framed. And thank you so much, sir, for answering them like in the perfect way you could have. Thank you so much, sir, and thank you everyone for being here.
Thanks, everyone. All the best. Hope to see you soon.
Thank you, sir.
Take care. Good night.
Okay. Good night, sir.
good night. Good night.
Thank you. Bye bye.
Bye.
Mahesh, sir, we can conclude the meet and turn off the live stream.